let's say that you had problem with the creation of the project, or it doesn't work. You can also import an already created cantilever beam example, and you do this by doing File, New, Tutorial, and then you press Next, and you just select http.cossan.uk, and then from here you can get pre-made tutorials. So you can select cantilever beam, and if I press Finish now, it will import a pre-made tutorial with this exactly the same model. Okay, so in case you had some problem in the implementation, because now for the next step we need to start from what we have already. That is a finished and working model, actually the quantification model for the cantilever beam. Okay, so I closed everything and kept only the model page. So we want now to see at other type of analysis that are still related to the design of experiment. You see my video, everybody? Okay. Yep. So let's as you saw before, we press the small play button, and we keep selected design of experiment. Now you can also change the analysis name, but for the moment we keep it as it is. I press Next. Before we just stop the deterministic analysis, now we can go to the next step, that is the design of experiment. And you can see that a new menu appears. These are various types of design of experiments, and you will find in the theory what they do. But two-level factorial is just combining minimum, maximum, all the variables together. Full factorial, you would say how many, which input you want to include into the design of experiment, and how many levels you want to input for them. When it's random variables that are unlimited, unbounded, they will put like the mean, then plus minus 1 sigma, plus minus 2 sigma, and so on. Box Bankian is something similar, but it combines the inputs in a different way. Composite design, it's again combining minimum and maximum, but in hypercube fashion, or the possible combination, and then user define, you just pass which value you want to evaluate. So let's start with the first one. Actually, let's start with full factorial. So how do we do the analysis? So we say full factorial, and we select all the variables that can be changed. So of course, we can only change variables that are the fixed variable that they cannot be changed in a design of experiment. Only the variable quantities can be changed. So in this case, that's why we are only seeing the random variables. We select all of them with shift click, and then we press OK. And you can see that it's saying how many levels we want to have for each variables. And let's put, for example, 3 levels for each variable. So this will be 3 times 3 times 3 times 3 analysis. And press Finish. Now, if we go to see UQ model results and then engine output, again simulation data, you can see that it's exactly 81 analysis, because it's 3 to the power of 4, because we are doing three points for each variable and doing all the possible combination of these 3 points of all the variables. What can we do with these results? Well, what I suggest is that we can, you see that in this side, there are not only engine outputs, but there is also a folder. What is the difference between the two? Engine output collect all the outputs that are coming from OpenCossan inside Cossan-X, depending on which analysis you're doing. What does it mean? That in this case, we are just doing a design of experiment, so it's just containing the object that has all the simulation data object. That is the object that contains all the input and output values that has been used in the analysis. In next steps, when we start doing the probability of failure estimation, we will have, in addition to the simulation data, we will have also object like a probability of failure object. Or if you want to do an optimization, if we do an optimization, we will see also an optimum object, and so on. When you are from this view, you have access only to open in table view. If I click on open table view, we close the previous one, you will see that we have all the 81 values of the inputs with all the corresponding value of the output. Now that we have more quantities, I want to show you something maybe more useful, how to export this data to a CSV file. So once you have the table view, you click on this icon here, that is next to the pattern, and you see it says export as CSV. So if I now click here, it tells me CSV files. So I say browse, and I will put, for example, a file in my desktop. I will name export full factorial. We keep it .csv, and then we can keep you can semicolon or comma. Let's put into comma, and then press finish. And now, if I go to my desktop, we have this export full factorial.csv. And if I want, I can open this into Excel. And this was regarding the question that we got before. How do we get the quantities from Cossan to Excel? It's like this. Now, let's go back to the GUI. As I said, this is just an overview of your simulation data, but maybe we want to have more detailed plots. Well, for this, we go to the folder containing the actual simulation data. This is the actual data that has been saved and is available here. So if I double click on this, I get an overview of what is inside. And you can see that I'm now looking inside the simulation database. From here, I was just getting an overview. This is just an overview saying what are the variables and how many realizations we have and so on. And here we are actually looking inside. Now, these things you can also open it from MATLAB if you want, because this is actually reading inside a MATLAB file. But the nice thing is if I select, for example, E, I can get all the values of the sampled. This is, you see, is the classic MATLAB display output. These are all the values of the full factorial analysis, and in fact, they are repeated every free. They are repeated. The same for P or rho and so on. But the nice thing that is much more interesting is that now I can select multiple of the outputs and multiple inputs. For example, if I want to see what is the relation between Young's modulus and the displacement in a kind of scatter plot, I can select E, and then with Control I select W, and then you can say Open Scatter View. Now in this case, they are both at the same time showed as two series of data, but I want to create the relation between the two. So I click on this X stuff. It says set variable for X axis, and I select E. So we put like on the X the Young's modulus, and on the Y the displacement. And this is the three values that are being used in the design of experiments, and all the possible values, because we have all the variation of the other variables as well. Even more meaningful when we have this kind of design of experiment is to do a parallel coordinate plot. So let's select all the random quantities that I want to remember you are E, P, rho, and B, and the output is W. So we select E, P, rho, and no wait, it was B or H random? Wait a second. Sorry, H is random. So let's select then E, P, H, and rho, and then W is the output. And then we click Open Parallel Coordinate View. This is showing all the possible combinations that we have done with this. You can see that it's just 3 points for each of them, and they are doing all the possible combinations. So from the 3 points, we get then 81 output. But the good thing, we can start limiting. So for example, we want to see what happens to the W when we keep, I don't know, H at the minimum and rho at the maximum. And this is showing, for example, these are the 9 outputs when we keep H at the minimum value and rho at the maximum value. In a similar way, you can play around and you can limit yourself, for example, to the middle or make high and high. And you can also reduce other variables and see what happens. So it gives us an insight of the functional dependency between the quantity. Now, in this case, it's just design of experiment, but you can see that when this is going to be completely random, it can also give us more information. Now, let's try to see another type of design of experiment. So let's go back to the model. Press play. We keep design of experiment, and we select now box banking. This is just fixed point, so we cannot put any parameter. We can only change if you want performance parameters, because maybe we are interested in smaller variation. So now by default it's getting the mean plus minus one sigma. So 1 plus minus 1 standard deviation, you can put 0.5 and then maybe only half a sigma or stuff like this, or 2 if you want 2 sigma. And now let's go back to the results. So for this box banking analysis, we did now 25 analyses. And if we look at the parallel plot as before, you can see now they are not anymore easy combinations before, but there is more variation because it's a different set of data that is checked, but you can read it from the theory. And again, you can play around with the range of the variables to have an idea of what is their effect over the output.